The experiment we'll be doing today is the Fireproof Balloon. Heat is transferred to liquids very quickly. Gases, on the other hand, are much less conductive and therefore heat transfer occurs much slower. Today we are going to take advantage of that effect and we're going to make a fireproof balloon. The instructions are fill a balloon up with air, place it underneath the fire, then do the same with a balloon filled with water. We will see what different outcomes we come out with. There are going to be 3 questions we will be able to answer at the end of the project, which are 1. What makes the balloon pop when there is no air in it? 2. What prevents the water balloon from popping? 3. Does the rubber have anything to do with this reaction to fire? Okay, so first I have my balloon. I'm going to blow it up with air. So this balloon is just filled up with air. And then I'm going to take my lighter. I'm going to place the heat directly underneath to see what happens. And it flew away. It popped. And then the next one is we're going to fill up a balloon with water. And I filled it up with water and I put a little bit of air. So here we're going to put the flame. The flame is touching the balloon. Nothing's happening. You can see the little burnt area where the flame's touching. Nothing's happening. But once I touch to the part where it has air and there's no water, let's see what happens. Let's scoot this back a little bit. It popped. Okay, so we did the experiment, and to answer our questions, the first question is, what makes the balloon pop when there is no water in it? The reason the balloon filled with air pops when you put the flame over it is because the rubber of the balloon gets very hot and it gets weak, and that's what causes it to pop. The second question was, what prevents the water balloon from popping? So whenever you fill a balloon with water instead of air, the water absorbs all the heat. So as the water is absorbing the heat, it's taking it away from the rubber. So the rubber doesn't get very hot. The water basically keeps it cool. So water has a very high heat capacity, much higher than air, of course, since it didn't pop. So it will keep the balloon from bursting. And the third question is, does the rubber have anything to do with the reaction of fire? Well, fire weakens the rubber and it causes it to burst due to the heat. So our conclusion is, when the water inside the balloon is placed in the flame, the water absorbs most of the heat from the flame. Then the rubber from the balloon does not become very hot because the rubber does not particularly absorb the heat. Thus, we have the fireproof balloon. When the flame is moved from the part where it doesn't have water, so I had it at the bottom where the water was, and we saw the burn mark from where I was heating it, it didn't pop. So basically the water was, I guess, it was taking all the heat, so it was starting to like bubble a little bit. I guess it was boiling. But whenever I took it to the part that didn't have water, which was the air, it popped right away and made a big old mess. So we made the fireproof balloon, and we saw that air is not a very good conductor of heat, but water is. So that concludes my experiment.